Good morning, students. Okay, so we will begin for today. So today we are going to complete fourth unit, and on Monday we will be starting the fifth unit. The topic for today is remote monitoring version 1 and the remote monitoring version 2. So last class, that is yesterday, we saw what are the different SNMP architectures. That is the previous classes. We saw the SNMP architecture, features of SNMP version 3, then the applications, and then we saw MIB, the security feature. So what are kinds of threats we can have? So we can have data. This data is getting masquerade, that is originality of the owner can be tampered, and then the data itself can be tampered, and you can have eavesdropping, that is your data is being viewed by some unauthorized users. So these are the kinds of threats and a network can have. We have non-threats, which are denial of service and then network traffic monitoring. So when these threats happen, they don't do much damage to our network, to our data. So we have classified them as non-threats. So the denial of service. So you are that is the hacker is providing multiple requests to the server such that the server is crashing and it is not able to cope up with the traffic load that it is receiving. So that is what is called as denial of service. So your normal authorized user is not able to access the network. So that becomes your DOS attack, denial of service attack. And the second non-threat that we saw was network monitoring, that is traffic is monitored by an unauthorized user. So what will happen if these threats happen? So you will have to take precautions such that you are able to cope up with these kinds of threats. So how the security feature is done in SNMP version 3 is using the encryption technique, and you are using the authorization techniques. For authorization, we use MD5 and SHA algorithm. For encrypting your data, we use the DES algorithm, the data encryption standards. The DES algorithm we are using to encrypt it. So next we saw what are the subsystems that we have in security module. So we have authorization module, we have privacy module, and we have timeliness module. So authorization module is responsible for data integrity and data origin authentication. So how the data correctness is maintained, so that is done by authorization module. And then data origin authentication, how it is done is whenever you transfer a message, a unique ID referencing that particular manager or the agent is appended with your message. So that gives you originality of the origin of your message. So next we saw privacy module. So privacy module is capable of providing data confidentiality. So it provides encryption techniques. So whenever you do encryption on the source side, you have to do the decryption on the destination side. So that is you are changing it into the original format. So for encryption and decryption, we have two keys: primary key, that is public key, which is known by everyone, and then private key, which is known only by the source and the destination nodes. And then timeliness module, in timeliness module, we saw how a particular time window is set. So the window time that is set for version 3 is 150 seconds. So within 150 seconds, the data has to reach the destination. If it exceeds the particular time, then it means that some kind of tampering has been done. So why we will be using it is when your data is received, there is your SNMP works on UDP, right? It is connectionless protocol. So whenever your data is received at the receiver end, it is shuffled such that it forms the originality. Data is originally whatever it was sent, it is received. So when this shuffling happens, the network hacker can change the order, and you can have a message which is meaningless, or the meaning of the original message is changed. Till this, we saw the MIB, and then we saw the security features, and then we saw what is the remote monitoring. So remote monitoring is you are monitoring a particular network. What kind of monitoring you can do is either the traffic monitoring or the device functionality, how much time the device is still running, when the device started running, all those kinds of monitoring we can do. So this is done by either by using your network monitoring system or by using a probe. So network monitoring system will locally work, okay, it will work within the network. It is capable of monitoring n numbers of networks. So next we have a probe. So probe is also a device, a physical device which has got inbuilt processor. That processor is capable of monitoring your network. So monitoring of the network is done either by the NMS, remote monitoring system, or by the probe. So this is what we saw, and then we have two versions of remote monitoring. That is remote monitoring 1 and remote monitoring 2. So remote monitoring 1 was further extended such that it can work with token ring. So first remote monitoring that was used was working only with Ethernet, and the second remote monitoring, that is extension of remote monitoring 1, that is your token ring remote monitoring. So these two remote monitorings were, that is extended version of remote monitoring 1 and the remote monitoring 1, were able to work only with the first two layers of the OSI model. So they were not capable of working with the higher layers. So in order to overcome that problem, so we have remote monitoring 2. So it is capable of working with all the 7 layers of the OSI model. So this was what we saw yesterday, and today we'll be further looking on to remote monitoring 1 and remote monitoring 2. That is the two versions of it. So first, this is just you have a data analyzer. So this data analyzer will analyze what kind of traffic, what kind of networks you have in the net system. So next you have a router, so through which we connect to our network. So next on your other end, you have a remote monitoring probe. So this probe will is nothing but it is just a physical device which has got a processor within it. So that processor is capable of doing the remote monitoring. So data analyzer is the processor that analyzes the data. So remote monitoring is a standard which is based for network management protocol. So it allows network information to be gathered at a single workstation. So this whatever networks, so this local area network, so this can be monitored by the probe. So this is about just an introduction for remote monitoring. So we'll be looking on to the remote monitoring 1. So remote monitoring 1 is given by your RFC 1756. It is only for the Ethernet. Okay, as I told you, remote monitoring 1 was used for Ethernet. Then we had extension of remote monitoring 1 which was used for token ring. But both these extended version of remote monitoring 1 and your remote monitoring 1 normal version was not able to work out with the higher layers of the OSI model. Only first two layers they were able to work with. So that is why we have the remote monitoring 2. So in remote monitoring 1, we have two data types that are introduced. One is source, and the second one is about the information that we have. And then you have 10 MIB groups that are introduced in remote monitoring 1. So these MIB groups are numbered from remote monitoring 1 to remote monitoring 10. That is different modules that we have. So the things that we have are two new data types and 10 MIB modules, MIB groups that we have. So what are those two kinds of data? So one is the owner string and the second is the entry status. So what does this owner string contain? The owner string contains the information about the owner. As the name indicates, owner string contains the information about the owner. So who is the owner of that particular remote monitoring system? So what is its IP address? What is the management station name? What is the name of the network manager? So where is it located? If at all, the telephonic number. So these informations are stored in the owner string. So it is like we have our own information, right? So once you buy a laptop, so when you go and see the settings, you will be having the information about the laptop. So you are the owner of the laptop. So you have your own user name that you provide. So you can be like an admin and you can have one guest a login also. So you are the owner of your laptop. Who is the admin? So that person is the owner of the laptop. So you have more privilege, more access rights when compared to the other user. So likewise, your owner string contains information about the owner. So which so we as we are able to identify the persons by their name, right? So on a network, we identify different devices by their IP address. So what is the IP address? What is the name of the management station? What is the network manager name? What is the location? So these things are available in the owner string. So next is the entry status. So entry status will indicate that is whenever we have a new component, anything, whatever network components we have, it is just entered in a table. Okay, we have seen the if table and augmented table, all those things, right? So the entry status data type is used to indicate the status. So it can be either valid, it is a create request, it is under creation, or it is invalid. So valid meaning that the component is available for usage. So it is available, it is still in working. So create request, you are creating a new entry onto the table. So if a new student gets admitted to your department, then you have a request from the admin to have a particular roll number for the student. So we identify the student by their roll number. So that is your create request. So you can have a request for adding a new thing. So next is under creation. So still that student joins the class, so we will have to wait, right? So we cannot mark attendance for that student until he joins the class. So even he has been admitted into the college, so we will wait until he is uh, getting into the classroom. So we don't mark attendance for him, even though he is admitted to the college. So that is under creation. Until it is under creation, you cannot use it. So invalid. So if a student gets TC and they is going to leave the college, so then that particular roll number of that user is invalid. So we don't use that particular student's roll number or register number. We don't use it. We don't reuse it, right? So that is what is called as invalid. So entry status data types contains four states. So it contains whether it says whether it is valid, whether it is under creation, and whether it is whether you are giving a request to create, and whether it is invalid. So these are the two data types that we have in remote monitoring one. So owner string and entry status. So this is just explanation. So as I told you, we just have it as a table, right? So once if the state is valid, okay, we have this four kinds of entry status, right? So if the state is valid, so row exists and it is active. So it is fully configured and operational. So if a student who is regular to the college, so you will be attending all the classes, you will be writing the test and all those things. So it is valid. So roll number, I will assume the roll number of the student for our consideration. So roll number of the student is valid. So next state is create a request. So if it is create request, so as I told you, a new student is admitted into the college. So a new row, you are creating a new row for this particular object, for this particular student. So you will be having a new roll number to be given. So under creation. So if it is under creation, then it is not fully active. That is, the student is admitted into the college, but he has not started attending the classes. So it is under creation. So he is yet to join the classes. So it is under creation. So if the student is still yet to join the class, so we don't mark attendance for the student. So we will not be able to use that particular row if it is under creation. And the last state is invalid. So if it is invalid, then it is of no more usage. So you will delete the row by the associating the map of this entry. So that is, you will have to specify the roll number of the student who has got the TC. So this particular thing is what we have for the entry status. So we have four states: valid, wait request, under destination and invalid. So every state has got unique ID. So that is 1, 2, 3, and 4. So this is about the owner string and the entry status. So next, the groups and the functions that we have. So you can see that we have many groups. One is token rate statistics, Ethernet statistics, then host and conversion statistics, filter group. So these are the different groups that we have in remote monitoring one. So here on your left, you can see that it is you have a remote monitoring network. Then you have the network manager on the other end. So in between these two components, we have this grouping and functions. That is how the remote monitoring works. So what are the different components it has got such that it is able to monitor the network. So first we will be looking about the data gathering. So what this data gathering will do is it will gather the data remotely from the monitored network. Okay, so whatever the network it is monitoring, so it will have to gather all the information about that particular network. So that network can be either an Ethernet or it can be a token ring network. So this data gathering is responsible to gather all the informations that are related to the network. So next we will be looking about the host and conversation statistics. So this has further components which are host statistics, host top end statistics, and the matrix statistics. So what will this host and conversation statistics do is it deals with the traffic of the data. Okay, it deals with the data traffic. So it is associated with the host or n number of hosts. So that is the work of host. So host and conversation statistics will deal with whatever is the traffic that is flowing on your network. And next you have this history control table. So you can see this history control table here and here. Okay, so this history control table is available in both token ring statistics and the Ethernet statistics. So what is the work of history control table? So this history control table controls all the data that are gathered from the different networks. So as I told you, the host, that is the network, can be either Ethernet or it can be a token ring LAN network. So they have different kinds of network, right? So this history control table will control all the data that is gathered from the various networks. So that can be used. Okay, so this history table can be used by token ring statistics and by the Ethernet statistics because those are the two networks on which your remote monitoring works. So these two statistics will have to use this history control table. So history control table contains data that are gathered from the various networks. So the two kinds of networks are you have token ring and your Ethernet. So this next is your we'll see about the filter group. Okay, so the filter group contains packet filtering, channel filtering, right? So what this packet filtering will do is, so the packet filtering will filter all the incoming packets. It will filter all the incoming packets, that is all the data that is entering into the network. So how it filters is by performing a Boolean operation. Okay, so what Boolean operation will be? It is either it will be XOR or any kind of XOR or an OR operation. Okay, so it will perform filtering of the incoming packets by a Boolean operation XOR. So you know what an XOR will do, right? If both the inputs are same, only then your output is same. Otherwise, it is zero. So it is it does that work of filtering all your packets that are entering into the network. So once the packets are filtered, then we call that filtered packet as a channel. So the filtered output is considered as a channel. So this output may generate either an alarm or it might generate an event also. So we are using packet filter to filter the packets that are coming into your network. So once it is filtered by doing some Boolean XOR operation, so the output of this packet filter we consider it as a channel. So this channel filtering contains the filtered data. So the output, that is after we do some filtering, the output of the filter can be either an alarm or it can also be an event. So once you have an alarm, like you have a trap or you have any kinds of notification, so when that happens, some conditions has to be done, right? So like how we have exception handling in Java and other programming languages. So once you have an exception, so what you do, the exception is being handled. So when an alarm is generated, you need some event to be performed. So that is done here. So the output of the packet filtering is given to the channel. So why it is given to the channel filtering is once it is filtered, we consider it to be a channel. Okay, so output of all these filtered data is stored into the packet capture. Okay, so once you have filtered the data, it can be either an alarm or it can be an event or it can be anything. So once it is filtered, the filtered data is present onto the packet capture. So what this packet capture will do is this packet capture module will do the analysis of whatever packets that it has received. So this analysis will be done by the network manager. So once the data is filtered, it is packet is filtered, it becomes a channel, and this is stored in the packet capture. So this packet capture will be analyzed by your network manager. So your network manager can do any kinds of analysis, whatever the data it has received on. So this is the groups that we have for remote monitoring one and its functionality. So once I repeat, so the data gathering will gather the information, all the data on the network, post and conversation statistics. So post will be either your Ethernet or it will be a token ring LAN network. So it contains all the information, all the data about the network. Next, we saw history control table. So history control table contains all the information about the host, that is the about the network. It is being used by token ring statistics and Ethernet statistics. Then we saw the filter group. So what filter group will do is what are the incoming packets it has got. So it will just filter it by performing a Boolean XOR operation. So once it is filtered, then we call it as a channel. So that is after filtering, you can also have either an alarm or an event generation happening. After all your packets are filtered, it is then stored into the packet capture module. So this packet capture module will be used by the network manager to analyze all the information that are available in the packet capture module. So these are the different groups and its functionality. And this is just uh, what these groups will do. So we have these groups like we have host statistics, matrix statistics, history control, Ethernet history, token ring history. So token ring statistics will contain all the information about the token ring network. So token ring history contains all the previous data. So all kinds of functions groups we have, right? So we have these groups and what are the remote monitoring ID that we have, okay, object ID that we have, what it's functional and which table it is associated. So as I told you earlier, so we have this entry status, right? So this entry status is nothing but the status of your table. So I was telling you that you have a new entry, you are deleting it, it is under progress, all those things, right? So in which table it is stored, so that is given here. So these tables we have for the particular group. So statistics group, its object ID is remote monitor 1. So it is link level statistics, the basic level statistics. So here you can see that it is ether status table and ether stats 2 table. So we have this number 2, right? So this number 2 indicates that it is an advanced version which is available in remote monitoring 2. Okay, in remote monitoring 2, we have the advanced table. So in every table you can see that you have a 2. So history control table you have, then you have history control 2 table. Next you have ether history table, then you have ether history 2 table. So these two numbers, whatever we have, indicates that it is an advanced table that we have for the version 1. So it is for the version 2 and then it is to differentiate version 1 and 2, you have a number 2 in between the table. So this remote monitoring group and table is common for both you have all these, right? So alarm, so it will generate some event. So post, so gathers the statistical data on the post. So matrix and all those things. So this is self-explanatory. So these are the different groups, and you have these remote monitoring IDs, object IDs, and its functionality, and the tables. So in table you have this 2 indicating that it is for the remote monitoring version 2. And if it is just normal table, then it is for remote monitoring 1. So both the tables of 1 and 2 is given in a single table here. So next, the relationship between the control table and the data table. So what we do is we collect all the data, so based on the source and destination address. So that is whoever is the manager and whoever is the agent. So we collect all the information from the manager or to the agent, or from the agent to the manager. So all these kinds of data are stored in an interface which we call it as matrix SD table. So matrix SD table, so we have this matrix table here, right? So we have this matrix SD table. So this matrix SD table and matrix DS table indicate all the data that are stored from, this is from source to destination, and this is from destination to the source. So all the information, whichever is the source and whichever is the destination, either the messages, that is we have basic messages that can come from the manager, like get request, get make request, all those things, right? So and the information, the message that comes from the agent will be a notification, like a trap. So all these kinds of messages that come from the source and from the destination, all these data are collected onto the matrix table. So that is the matrix table we have here. And then we have this control table and data table. So what is the use of this control table? So what this control table will do? So control table contains many entries. So first one is control index. So this control index is an integer. So as the name indicates, it is an index, meaning that it is an integer number, a unique number that identify all the rows in the control table. So remember that it's a table kind of a thing. So every entry in the table is to be identified uniquely. So how we identify that entries into the table is by maintaining a control index. So it automatically gets incremented every time you add an element into the table. That is your control index. So it is just a integer number, it is a unique number that is associated with every row that you have in the control table. So next is control data source. So what this control data source is, it is used to identify the source of the data. So you are collecting the data, right? Either it can be from the source, destination, or it can be from the source. So where are you collecting the information from? So that is given in the control data source. So it identifies the source of the data that is being collected. So that is your control data source. And the next one is control table size. So what is the size of your table? So how much entries you have, how many, the number of rows you have, so that control table size is mentioned here. So it identifies the entries that are associated with the data source. So next is control owner. So who is the owner of that particular entry into the table? So owner can be any object or any devices that we have. We call them as entities, right? So it can be either any kind of entity, or it can be your manager, that is your network manager, or it can be your remote monitoring system itself. So you can have the entries onto the control table either by the device, any kind of physical device we have, which we call it as entity, or it can be either a remote monitoring system itself, that is your network monitoring system, or it can be your management level persons like the manager. So that is what is stored in the control owner. Next is control status. So this indicates whether the data is still valid. And then we have the other controls. So in other controls, we have this data entry data table. So this data table contains index, add index, and other data. So what we have with other data is this other data will indicate the data whatever we are collecting from. Okay, so we are collecting some kinds of data from the network by monitoring it, right? By remote monitoring a network, you are collecting few things that are specific to the network. Like you can collect the number of incoming packets or the number of outgoing packets at a particular time. So as I told you yesterday, like on the daytime, you will Google search engine will have more number of requests than when compared to the night time. So we are monitoring according to the requests that we are receiving. So number of requests the Google server is receiving can be more during the daytime when compared to the night. So likewise, this other data contains the data that is being collected. So the number of incoming packets or the number of outgoing packets, any kind of things that can be dealt on by the network. So this data index and add index, data index are associated with the data. So that's about your control table and data table. So control table contains all the information regarding what is the who is the owner of the table, who is the owner of the information, and where your information comes from. That is your data source and what is the size of the table and all those things. So main thing that you need to know about the data table is it contains all the information about the data that you are collecting from your network. So that is the relationship between the control and the data table. So next you have the extension for remote monitoring one, which we call it as token ring extension. So token ring extension is available in your RFC 1512. So you have two token ring statistics group. Okay, one which works at the MAC layer, so that's your token ring statistics, and the other one is used to collect information about the network. Okay. So in order to get information in terms of packets, so we'll be using the second group. So one group which contains collects information about the network, and the second one contains information about the network in permissionless mode, that is in terms of the packets. And these are the different groups and tables that we have for the extended version of remote monitoring. So we have this statistics group, we have this provincial status, we have the MAC layer history, and all those things. So what this MAC layer statistics will do is it will collect data on the token ring parameters. That is a token on your token ring will collect the data. What kind of data it can collect is the number of packets. Okay, so it can be what is the incoming packet, what is the outgoing packets that we have, and it can be like error messages, what kind of error messages that are happening. For example, if you have authentication problem, so if you are not able to access the particular network, so what kind of error situations can happen. So all those things, and then the number of packets that we have, so that those can be available in the MAC layer statistics. So next is Prometheus statistics group. So this statistics group will address the utilization of the network. That is same thing, the size of the network and the type of the packet. So whether it is broadcast or multicast. So broadcast, you know, it is like a one-on-one, and multicast is one to many kind of things. So what kind of packets that you are transferring, so that can be available in the statistics group. So source routing, it utilizes the statistics of the source, that is information about the source. For every statistics that we have, every ring group we have the table. So like how we saw previous, right? So everything, whatever we have, it is under a table. So we for this table entry only we saw the entry status data type. That is either it can be valid, it can be invalid, either it can be under creation or for create or request. So every data that you collect on the network can can depend on some group. So if it is a ring group, so it contains information about the token ring. Suppose if it is a MAC layer group, then it contains information regarding the MAC layers. So those kinds of data are to be added onto the particular table. So what table it is to be added, that is given on the right side. So here in this table also you can view that you have this two, right? So you can see ring control, ring station control to ring source routing status to table. So this indicates that it belongs to the remote monitoring 2. So if it is 2 number, if it is in between the table name, then it indicates that it belongs to the remote monitoring version 2. So both for the remote monitoring 1 and 2, the table is listed here. So next is about the remote monitoring version 2. So this is an extended capability that is it is able to work with the higher layers of the OSI model. So as I told you, the remote monitoring 1 and its extended version were available only with the first two layers, physical and data link layers, but it was not available at the higher layers, that is the transport layer, all those layers, right? Physical application layers, all those layers, you were not able to monitor those kinds of layered network architecture that we have. So in order to monitor the entire OSI layer networks, then we have this remote monitoring version 2. So we can have some kinds of error, right? So whenever you are monitoring network, you will be able to identify what kind of problem you are facing. So if you are able to identify that is whatever errors you are able to identify in the higher layers, that can be identified in the lower layers also. That is assume like inheritance. So whatever you have in the that is your base class, that can be inherited by the child class. But whatever properties you have in the child class, that cannot be inherited by the super class. So like same thing, whatever errors that are able to be handled in the upper layer, that can be handled by the lower layers also. But the reverse is not possible. So the example given here is the network layer errors do not include the data link layer errors. So, but the transport layer errors can include the network layer because it is the higher version. So whenever you have a higher version, it can cope up with the lower version also. But your lower levels cannot cope up with the higher level. So that is what is mentioned here. And for the remote monitoring to MIB, so I have a diagram which I couldn't accommodate within the slide. So it is available in the page 445 on the Mani Subramanian Network Management book. We'll just go into it. Yes, so this is the table that we have. So you have these entries into the table, right? So you have protocol directory, you have protocol distribution, address map, and in version 1, we had the MIB group from 0 to 10. If you could recollect the slide which I showed earlier. So we had this MIB group from 0 to 10 for remote monitoring version 1. So for remote monitoring version 2, we have the remote monitoring module from 11 till 20. Okay, we have 10 more modules that are included in the remote monitoring version 2. So we have the corresponding tables in which all these data will be added on. So this is about the remote monitoring MIB for the version 2, its corresponding group and its table. So this is just self-explanatory. You can just go through it, and then so next is conformance specification. So we have remote monitoring 1 and 2, right? So whenever you have more than one versions, then you will have to, that is, your vendor should be capable of producing your components such that they are capable of working with both the versions. So this conformance contains two sub-components, sub-modules, which is MIB, there is two complaints and then MIB groups. So these groups we have already seen earlier. So this further it is divided into basic MIB complaints and MIB complaints for the application layer. So this basic complaints will contain, that is, it can have either mandatory groups or it can have other groups, like how we saw earlier the version SNMP version 2, 3, 2 complaints, that is conformance. We can have a mandatory group which is to be implemented by all the vendors, and we have other groups which can be specific to the particular vendor. So these complaints have to be taken into consideration when you have a product that is being manufactured by a particular vendor. So this table indicates whether it is a mandatory group or not. For example, your protocol directory group, okay, so it is mandatory. So M indicates that it is mandatory. So it should be, that is whatever vendor, it should produce the component such that it works with the protocol directory group. So if you could see a host group, so this host group is not mandatory for the remote monitoring tool, that is the basic level, but for the application layer, it is mandatory. So this M indicates that it is mandatory, and then O indicates that it is the other one, that is it is not compulsory. So we have these kinds of groups that have to be mandatorily given by the vendor for the basic. This is your basic MID, and this is the remote monitoring group application layer specific. So that's it for today. So we have completed fourth unit. So today we saw what is remote monitoring 1 and what are remote monitoring 2. So if you have any doubts, you can ask me. Otherwise, you can leave the class. Thank you, students.